Thank you very much for coming. I appreciate you taking some time during the lunch break to come and listen to me rant a bit about passwords. A little bit of a disclaimer, if you really like passwords, this might not be the talk for you because I'm going to talk about how we might get rid of passwords. Who likes a password? Who likes to type in a password over and over and over again each time you visit a website or open an app? Nobody, right? Let me quickly introduce myself. There it goes. My name is Bellen. I'm from Belgium. I do speak some Italian, but if I would be talking in Italian, you would just run out of the room because of my accent, so I will not do that. I'm a developer advocate engineer at Auth0. If you've never heard of Auth0 before, we're an identity as a service company, which basically means that we try to make it as easy as possible for any developer to implement a secure authentication flow so you can focus on building your actual products, your actual apps. I'm also a Google developer expert, and I organize a few meetups. One in Belgium, Frontiers, and one in London, the Identity and Security Meetup. And you can find me on the internet as Sambego. Okay. I have cat stickers. So if you like cat stickers, send me a tweet of your cat, your dog, your bunny rabbit, or whatever animals you have here in Switzerland, and I'll give you some cat stickers after this talk, because who does not like cat stickers? At least I do. A bit of history on passwords. They've been around for a very long time. Romans used passwords. If a certain legion of Romans would encounter another legion and they would not know each other, they would use a system of passwords to determine if they were friends or foe. If the password was okay, they would go out for a beer. If the password was wrong, they would start to fight. So passwords have been around for a long time. There's also this famous story written in the 10th century about Alibaba and the 40 thieves, which had a cave full of gold. And to open that cave, the 40 thieves would use a password, open sesame. Again, an old example of passwords. But if we skip forward a bit to 1961, the first implementation of passwords on a computer or an IT infrastructure was created by Fernando Corbato. He worked at MIT, and back in the 60s, not everybody had a computer they could use on their desk or in their pocket or at home. They had one computer at MIT, but they had a lot of researchers who wanted to use computer time. So this guy invented a time-sharing system. It basically meant that they shared the CPU, that they shared the hard drive with as many people as possible, and everybody could unlock a certain part of the CPU of this hard drive with a password. So since the 1960s, 61, passwords have been in use on computers. And in the 1970s, Robert Morris Sr. invented hashing. He worked at Bell Labs, which means that at least the first 9 years of passwords on computers they were stored in plain text, which you should not do. So if you store passwords, you should hash them, you should salt them, you should do a lot of things with them. This talk is not about this, but they've been around on computers since the 60s and have been improved upon ever since. And then in the 90s, the web became kind of exploded. There were services every day, new services. It still happens like this, but because of these more websites, these more apps coming onto the scene, hacking became more of an issue, so people try to steal passwords. And you know that when your password gets stolen, everybody has access to your service, to your app, and that's not good. So what's the problem with passwords? A common example is a username, a password. You try to log in. So if I try to log in, of course, you never type your password correct from the first try. So don't even expect that to happen. So you try a second time. Still not correct. Third time's the charm. Still doesn't work. So what you do, you're going to change your password. You're going to reset it, so you type a password. And when you reset it, you get this kind of message. Who's ever got this message? I have, because I always think that I know my password, and for some reason I get a bit retarded and I'm not able to type when I have to type a password. I can type a full book without an error, but I cannot type a short password without an error. So I tried to reset it, and it turns out I knew my password all along. So passwords can be annoying. The user experience is not correct. You have to remember them. You kind of want to have a complicated password, maybe a bit longer, so it takes a bit more effort to brute force them and stuff like this. And passwords can get stolen. It's almost every week that you hear about a certain service getting hacked. Luckily, most services already encrypt them and salt them and hash them and whatever you want, even though sometimes you hear about a lot of user data being stolen, which was just in plain text in databases. Even the big ones, the big companies sometimes forget to encrypt their data. So if they get stolen, that's annoying, and that's a flaw in passwords. Especially since I told you that there's so many services coming every day since the 90s. people are actively trying to get the user data, to get the username and passwords. So there might be a better way than using passwords on the internet, also on mobile phones, on any kind of app. But on the web specifically, it's called the Web Authentication API. Who's ever heard of the Web Authentication API? A few people, okay. Perfect, because I want to explain this, and if you all knew about this, we could just go grab a beer. We're not going to do that. It's often abbreviated as WebAuthn, because we're developers, we're lazy, we don't like to type Web Authentication API. WebAuthn is a bit shorter. If you want to Google some information about this standard, this is more effective than the complete name. But what it is, it's a key-based authentication mechanism on the web. You have private keys, public keys, and you use them to authenticate, to register on websites, and you don't have to use a password anymore. You're going to use these keys to authenticate. They're often, or they're always, in combination with a hardware authenticator, which can look something like this. Looks a bit like a USB drive. This one is a USB-C version because my laptop has USB-C, but you have a lot of them. You have them in Bluetooth if you want to use them on an Android phone. You have them in regular USB. This one is the Google version. You have them open source, which you can hack if you want to. And then you have just regular USB-C ones. And this is just a USB drive in the form of a beer bottle, because I'm Belgium and I like that. So you have them in a lot of different form factors. USB-C, Bluetooth Low Energy. You also have NFC if you want to use them on an iPhone. Might be possible. There is a new version of a YubiKey which just came out, which also supports Lightning, so you can plug them into your iPhones and iPads. So they come in a lot of different form factors, but they're always hardware devices which contain a private key and can generate public keys and can sign challenges and stuff like this. So who has one of these devices? Few hands, not too many. And that's a bit annoying, because if you would look at an example, instead of typing username and password like before, we just have a login button, maybe a username input just to identify who we are. And if we click on it, it asks me to touch one of those which I have attached to my computer. If I touch it, mine is protected with a PIN code. I enter it, touch it again. I have to allow it because I'm on localhost. But what it does is I send a challenge, a random array buffer, let's call it, to that authenticated device. It signed this, it generated a public key, which it sends back, and it also sends back the ID of the private key that has been used to sign this challenge, which is what we see here. It's just an ID of it. The private key stays on the device. Of course, it has to remain private, but you can identify the private key that has been used to complete this registration, this authentication request. So if you have one of these devices, very cool, but I saw maybe 4 or 5 hands, and we're here with a bit more people. The good news is most modern devices have a built-in authenticator device. Who has a device that's younger than 10 years? All of us, I guess, or I assume. So most of these devices have one of these authenticator devices built in. It's usually a special dedicated chip, like the Apple A2 chip. Intel has their own version, AMD has their own version. Every chipset has one of these chips that does nothing else but having a private key and is able to generate new public keys from it and is able to sign challenges. So if we would use one internally, I have a MacBook Pro, which is Touch ID. So if I would click on this button, it would ask me to touch my Touch ID to unlock my special chip. And when I do so, I have to allow it because I'm on localhost again. And again, we get back an ID of a private key. So now I use my built-in one, my platform authenticator. I unlocked it with my Touch ID instead of using a PIN code, but it did the same. It signed the challenge, sent back a public key, and sent back the ID of the private key that has been used to sign that challenge. So all of us have access to these kind of authenticator devices in one way or the other, either to a USB or to a built-in one. Which is awesome, because we can all benefit from this new web API that allows us to authenticate with a private and public key system. So how does this work? It works in 2 steps. Like when you go to a new website, you first have to create a new profile, and then you enter your password, and then the next time you can log in with that username and password. The same goes for this Web Authentication API. You first have to register your credential. You have to register your authenticator device that you're going to use with this platform. So you choose a username, something that can be used to identify you as a user. You send it to your authorization server, and this will send back a challenge. The challenge is just a random error buffer, random buffer with some random values, and we send that challenge to the authenticator device, which requires most of the time a user interaction. I have to touch the USB device, I have to touch my Touch ID. If you're using Windows Hello, you can use your face recognition as well. So we use this user interaction, and this is going to sign that challenge with the private key and send back that signed challenge, a public key, and the ID of the private key through that API. And you can store this in your database because it's all public data. So once registered, we now have a authenticated device that's linked to our user. So the user can use the same device again and again and again to authenticate. So again, the user says, hey, my name is Sam, and I would like to authenticate. We're going to do a lookup in the database, like, did we store some credentials for this user? Oh yeah, we have some credentials, and the previous time they registered with a private key that has the ID X. So we send that raw ID back to our authenticator device, and it's going to use the same private key to sign the challenge. And because we have the public key already stored, we can then verify that it's the same private key that signs the challenge. User interaction again, send it all back to your authorization server. And if it all matches, we know that it's the same user, the same device that registered before and now is trying to authenticate your user on the web. So let's look at some code. It's a very straightforward code. It's JavaScript. I know there's a lot of Java developers here, but it's a web API, so it's always exposed through JavaScript by the browsers. The first one is to create a new set of credentials to register. And what you're going to use is navigator.credentials.create. This accepts a whole, a big object with a lot of config parameters. The first one, of course, is your challenge, your random data that you're going to send to the authenticator device, which is going to sign, and you're going to get back. The second part is some information about the relaying party. It's often, or it's most of the time, the authorization server or the website you're trying to register for. So if you want to register on my website, sambigo.tech, that's going to be in there. Another part is some information about the user. Again, a user ID, which is used to identify it, and some extra data like a name or a display name. Important is that you cannot put any identifiable information of the user in that ID. It has to be completely separate from the ID, from the name or the display name or an email address or whatever, because it's a buffer. You can put in whatever you want, but it has to be anonymous. Next up is a bunch of algorithms that you want to support with your website or your service. So it's just an array, and you specify a bunch of algorithms. -7 does not sound like a real algorithm, but there's a whole list on the IANA website which has a lot of values, and if you would look up -7, we would get to ES256, which is an algorithm. So instead of typing the whole names completely and maybe making some mistakes, there's this list with these short numbers which you can use to reference certain algorithms. Oops. You can put as many in here as you want, as long as you know how to validate these or how to work with these algorithms, you're fine. Next up, timeout. This is the amount of time the user has to complete the action, touch the USB drive, type in the PIN code if it has one, touch your Touch ID, or do the Google, the Windows Hello face recognition thingy. It's in milliseconds, so in this case, it's 15 seconds. And then if you want to exclude some credentials, you can do this as well. This has some use cases. And next up, you can filter which kind of devices you will accept as a service. For example, you can only accept platform authenticators, which are the ones built in Touch ID, Windows Hello, stuff like this. You can also do the opposite. You can also only accept external ones, like the USB ones, the Bluetooth ones, the NFC ones. If you prefer that, you can also allow both of them. That's perfectly fine. You do this with the Authenticator attachment, platform for built-in, cross-platform for external ones. You can also do user verification, which means that the user has to verify himself when it tries to authenticate. Touching a USB device does not really verify a user. It verifies that somebody is doing something, but does not verify who's doing something. Well, if you would be using Touch ID, it will read my fingerprint, so it can verify that it was me who was doing the action of authenticating myself. So you can set this if you want, and requires resident key. We'll see a bit later. And then lastly is attestation. If you want to get the data directly from your authenticator device or maybe if you want to anonymize the data a bit, you can set this in this attestation object or value. And then once you've created these credentials, you can use navigator.credentials.get instead of create to use previously registered credentials. Again, it accepts some config, a challenge, we've seen this, random array buffer. Then the allowed credentials, so you will pass in all the credentials you've saved in your database for a specific user in this object, so you know that if a user is trying to use private key with ID X and you save that one in your database, you're going to put it in here and it will only be allowed to authenticate with that private key. Some other things like user verification, again, if you prefer this, you can set it again, but it's a bit smaller to authenticate than to register. Now, we've seen resident credentials in that config as well, and they're a bit special because up until now, we saved the ID and the public key in a database somewhere on our server, but ideally, we do not want to do this because it's still data that can be stolen. Even if it's public data, it's still something we do not want to keep, or maybe not all the time. And there's resident credentials. And basically, a resident credential is a credential that has been saved on the authenticator device instead of on the server. So if we set this to true, we will save our user information together with some other data on the authenticator device. And let's see how that works. So we've created this little website called webauthent.me, which has a bunch of information and also a debugger, which lets you play around with all of the config you can pass along. So if I would use Voxed as a user and display name VO, give myself some time, and I would enable the required resident key. I can now initiate the registration request. I use my USB drive. I touch it, type my PIN, touch it again. So basically now I've registered for myself with the name Voxed, because we're at Vox Day, and I saved those credentials on the authenticator device. The next time the user wants to authenticate, we use our get method, but instead of specifying a set of credentials that we have saved in the backend, we're just going to leave it empty. And if we would now click on authenticate, touch the key, type the PIN, touch it again, we would see that we have the Voxed credential together with some previously saved credentials there. So if I gave myself a bit more time, so let's put this like this. Next, touch it. If I would click on Voxed, I would be able to just authenticate with that user because I've registered with it previously, and we see that it worked. We get some data back. So with resident credentials, you can save the credentials on the authenticator device, which means the user does not even have to input a username because they can just click on the username or the users that have been saved on that device, which is pretty cool. Well, the thing is, your challenge you're always going to create on a server because of some vulnerabilities. So you're going to generate them so they cannot be used in a replay attack, for example, and going to send them from your server to the front end. But most of the other stuff is happening either in the browser or on the authenticator device. So if you want to save the credentials again, you're sending them back to your server, but most of it happens in the front end, yeah. But these authenticated devices are, you should not be able to access them, so they're not readable. They're not a real USB drive, so your data on that should be safe. That's the whole point of these devices. If you want to play around, webauthent.me/debugger, there's also a bunch of information and a little tutorial which shows you what's going on, but we don't have time for that. So there's still some issues to be solved. User credential management. You can create users on these devices, and you can delete them all, but you cannot delete a certain credential, or you cannot edit a certain credential yet, which is annoying because if I have a certain user I want to delete from my authenticator device, I have to delete them all at the moment. Cross-device credentials, if you create a credential on a certain device, like for example, using the built-in one on my MacBook Pro, I cannot use that credential on my phone. I have to register with my phone again, which is not a big deal, but it would be nice if you could reuse credentials from multiple devices. And if your device gets lost or stolen or broken, you might get logged out of your service because you don't have access to the Authenticator device. That's why you should always have a backup, like an authentication authorization code or whatever, or maybe a password as a backup, who knows. As long as it's not your primary, I'm okay with that. And it's a W3C recommendation. It's an official spec. It's been through all the stages of the W3C process, and it's a recommendation, which means it's finalized. Works in most modern browsers, and since Safari 13 last week or 2 weeks ago, it also works in Safari on desktop, not on iOS. I don't know what's going on with that. I have to figure that out. So where can you use this? Any big website supports this already as a second factor, because there's still a few things that needs to be figured out, but most of the big websites support this. Again, if you want to know more, webauthn.me with the debugger. We don't save any of the data you put in here. It's all safe. Webauthn.me or the spec. We have some blog posts. You can find the slides at this link. I'm going very fast because my time is up. So if you want to see the slides again, the slides here are there's a bit more slides in there, but it's the same content more or less. Thank you very much.